Hello, and welcome to another video on the intermediate React. So this course is taught by Brian Holt, this software engineer that has really worked at Microsoft, Reddit, Netflix, and he is now currently the PM of Snowflake, this database as a service provider, this database as a cloud server provider. And the idea of this model and this course is to be able to write production ready React applications and learn the techniques and strategy as well as a tool for that. In the case of the techniques, looking at the code splitting, server-side rendering, testing, as well as transition. And for the tools like TypeScript, Tailwind, and Redux. So this course is break down into several sections. So we have first is the hook and depth, then tailwinds, then advanced techniques, uh, this advanced React performance, a low priority re-rendering, TypeScript, Redux, and testing. Okay. So first thing first, we'll look at the hooks in depth. In today's video, what I'm gonna do is this quick recap until finally hit the advanced React performance, especially the code splitting. So I'm gonna make a quick recap of these two courses, which is not that long, and how hooks in depth, because React has several ways of how you can achieve certain specific things back in the previous model or looking at the core of React, for example, in the intro to a complete intro to React, which is also a course taught by Brian Hall. So he will look at how you can now make sense using React. So what is the value proposition of React? How you can use React on your browser using a CDN, and then the core of React, uh, such as looking at the uh, such as the GSX hooks, functional components, use effect, custom hooks. Also look things like uncontrolled forms and control form. The component composition, some guidelines as a way to create and follow this. The way how you can use React DevTools, as well as some side notes, such as the no flag to identify which React bundle you're using, whether it's production or development. And the other is um, how you can use tools that allow you to speed up the process here, such as ESLint, this code linter. So pretty much like is in your if you have an essay, if you have an English essay, this will indicate is what is the style of writing you need to use. So this ESLint is helping you with fixing common JavaScript problems. Prettier, the code formatting, so pretty much like giving you format in your English essay. Hey, this is the paragraph. Does this paragraph have the proper space? And finally, the Vite, which is the dev server, as well as other type of tools that we're going to see is on here in the intermediate course, like testing and unit testing and TypeScript, as a way to help you with the correctness of your application. So by looking now at the React core and also the React capabilities, such as the React router, the React query, what is the value proposition of each one of them, and the class component, which is something that we did we did a pretty good job and look at what is the subtle difference between the React functional components and class components, and then the special cases of React, such as models, error boundaries, and context. You have to be very careful when you use that, especially context. So now here, as a way to complete our knowledge with React version 18, is to say, hey, okay, so what is this hook in depth? So, which is, again, Facebook has particularly problems that they need to solve them. The vast majority of our company won't have that kind of problem. But even though it's important to understand when you can use it. So, for example, we look at use ref. It allows you to hold a reference on a object so we can let it on use it. For example, using to create a timer or a stopwatch where you need to hold the reference so when the user stop uh, you stopwatch, well, you can now not only send that set timeout functions to the web API, but also capture that when that time is over and run a function and do something about it. And the other is using to capture a DOM element. So use ref is like putting stickers in different things on your room. When this, when you put that information uh, on each one of those stickers. So this is use ref. The other is use reducer that allows is to keep track of whatever a state change, something very, very, very important, especially on the UI development, because this is what can cause the most burdens as a way to know what is the current state, what will be the next state of your UI, and this use reducer is just a fancy function to say, hey, I receive is the current state and an actions. I'm going to return a little bit of new state. So that's what it does, use reducer. A real life example of this is, so for example, what will happen if you are a business owner and you want to keep track is what's going on at your pizza restaurant. Okay, you want to know um, which ingredients has been used to a particular pizza. How many orders uh, do you have? Uh, how many time the chef is taking to prepare that kind of thing. So this allows you is to control is the different state change in your pizza or in your entire uh, business workflow, and you can check what's going on, what changed at each different stage. That's interesting. Uh, Another hooks is use callbacks and memo. This is very, very specific to React performance. And the idea here is if you component are rendering is other React components, notify that should only be rendered once. Okay, that's the purpose of use callback and use memo. Again, you're gonna depend on when you wanna use that, but that's the overall use case. Another hooks the use ID that allow you to now add is some identifiers specifically for form You don't want the so even React community, React developers, they don't allow you to use on default because the way how they generate those ID, and they tell you in the docs you shouldn't use to render elements, to uniquely identify elements in your component. If you're rendering a list of React components, no, you shouldn't do that. You should rely on your own data, perhaps using the UID package as a way to guarantee uniqueness. And then I look at the use layout effect, which is pretty much behave like the use effect, because use effects calls after the render functions end. However, because these functions doesn't run synchronously, which means that it won't wait for the render to, or it won't wait for the for your component to be rendered. It will trigger immediately. So this is pretty much like this next X, the animation frame. It will wait for that frame to work. It will wait for that uh, function. So with use layout effect is to say, hey, I would like to wait for that function. So when everything is rendered, now I'm going to run this callback. And that's pretty much uh, yeah, that's pretty much it with the React, with the use effect layout. When you want to use it, well, for example, when you give the ability to users to resize element on the DOM, okay, pretty much like if you're building a design tool where now they need to actually resize elements, circles, squares, star elements, lines, you know, this allows you to actually is render your element once. When that state change happen in after the render function finally renders the element. So okay, remember that after all, React, the sole only purpose of React is to render components. That's all. So then we look at Tailwind, okay, which was very interesting with Tailwind. Something that I have experience with. So Tailwinds is a methodology to write CSS. It's not opinionated. It's not like Bootstrap or Material Design when they are UI design systems. So if you build a website using Bootstrap, you will know that you've used, uh, or it will look like a Bootstrap website, which for internal use, when the look and feel is not required, but you need to have, or as long as this is nice and usable, yes, all the way with this UI design system. Uh, and the idea of using Tailwind is because this is a way of how you can write your CSS. It has a compiler that you're going to indicate all of the different tiny little classes in your HTML. And from there, it will output is a minimal CSS code from that. This particular approach of this little tiny class or utility class based CSS is way much more easy to maintain than large CSS code bases, because now you don't have, for example, things like conflict or CSS conflict, for example, in global objects or in a specific CSS files, right? Even though that you want to make as small as possible, but the idea here is that it's much more easy to maintain a utility CSS class approach code base because it's much more easy to maintain HTML code. Alright, with that introduction, now we take a look at how can we install TypeScript, what are the things that is using behind the scenes, also as a way to make sense of what the React community and the front-end community actually is using as a way to speed up the development of UI elements, such as post CSS, which is something that I already have quite a lot of time. So post CSS here. Mm-hmm. So yeah, we got post CSS. This like Babel for CSS, a tool for transforming CSS with JavaScript. So you can think of this as the Babel of CSS, where the architecture is that it takes this input uh, and pass that through a parser, and that parser will pass through all of these plugins or post CSS plugins to finally generate and stringify is an output that will be understood for any browser, or that will be understood by any browser. Now, another plugin that we need to use is the auto prefixer, which allows us is to use is the new CSS model features in that works in any browser. So that's exactly what we did. And we strictly fit the versions or we set or we lock our package versions strictly because we want to make sure that this actually works as expected, no matter how many months, years, decades this can pass. I don't think that, quite frankly, I don't think that this application or perhaps this long will live that long, not decades, uh, because the way of how everything is working and how these frameworks and tools are actually moving based on the demands, the industry demands, as well as the user demands, and developer. So in any case, so to make this work, we fit that, we lock the entire package. Okay, so then we look at how can we enhance and how we can styling our applications using this little tiny CSS class. How also we can make use of prettier as a way to make sense of as a way to organize our code with Tailwind. Uh, Sometimes you might experience some issues with prettier. Uh, Something that you can easily fix with GitHub Copilot, all right? And then how you can extend the Tailwind CSS by including it first is on the style CSS, all of these Tailwind rules, which is all of these Tailwind CSS rules. So for example, we have base, we have components, and utility. So this follow is a particularly precedence, order of precedence. So utility override the components and all components override base. And base is actually to indicate what are the different CSS styles you want to reset, for example. Uh, hey, how the body should look like at the beginning, and that kind of thing. The component is like, hey, how this particular title should look like, the H1, the typography. And then on utility is more like, hey, it's taking the modifiers, CSS modifiers, okay, like the selectors here. It's not selectors, it's exactly it's selectors, like this kind of selectors here. It's like, hey, is this active or not? Hey, if this link is Hey, on hover, which is something here. Hey, on hover, is this hover or not? What you gonna do when that happens? This is pretty much like this utility here. So yeah, all right, and then okay, and then we also look at how can we extend that by using Tailwind's plugins, for example, the form as a way to reset all of this. Uh, when you're using form with inputs, how can we now how can we use that with or to enhance the tailwinds by using as the layer for that? Something that we don't add that here, but by using layers, it allows you to layer in one of these particular CSS rules and utility or components. You can now extend the tailwind CSS, reusing their tailwind, uh, yeah, reusing their tailwind, reusing the tailwind's utility functions. So this is something very, very important to describe here, especially is that switching context is destroying your productivity. And that's, my friend, is one of the things that I put here. So anytime you find yourself switching from one context to another, hold on, don't do that. Find a way to wrap it up to finish what you're doing, and then you move on to the next task. This is also more like a philosophical, like a psychological tool that you can use, especially if you need to move from one task to another. So keep in mind that it will take some time to actually get used to that. So first things first, do the work in this particular task. If you find with a huge roadblock, take a uh, take a walk or meditate. That also can help you there. Uh, and then you come back here. All right. This to me was very, very important to describe whatever task you're doing, especially if you're learning something like in today's video. Yes. Okay. Now, the other interesting thing is the layout with CSS, which is something that I'm quite familiar. It's using all of these particular breakpoints, and you're going to indicate what will happen when those breakpoints happen. So, for example, when the viewport is small or is greater than 30, 40 pixels, hey, you should now display my layout in two elements using grid, for example. Grid and grid color, and then you set that to two elements. Hey, but when this is large, I want you to now show three elements. This particular way is of creating layout is something very, very interesting and powerful. You're now delegating a lot of the heavy lifting to the browser, which something that 4 or 5 years old is actually quite hard to do that. Thanks Tailwind for that. So now, finally, the advanced techniques, which is the performance. First, we look at the code splitting. So the idea of this is if you want to, yeah, with code splitting. Uh, the idea of this is to improve the performance or the perceived performance by splitting your code into the necessary minimal that teach your app to set up everything that shows something immediately to the users, and then in the background hurry up everything else. So this is something that is quite uh, interesting, this particular technique or strategy, because once, so with code splitting, there are several ways of how you can actually do that. The idea behind that is, for example, if you want to set a, if you want to stay under or reach a performance or or time in performance to hit, okay, you need to have some code budget. Uh, Most of the time we follow is Web Vitals for that. And this code, what in this code budget is something that, for example, when you're implementing this technique in React, you're gonna do that at least of 10 kilobytes. So let's say you want to stay under 100 kilobytes. Uh, so for that, if we take a look now at the React libraries to gain a little bit of context, so the React developer service as well as the React DOM, okay, something that even with this data comes from Bundlephobia here, okay, React, React DOM. So these two libraries, roughly speaking, weigh less than their bundle size is interesting. And it actually pretty fast, by the way. Uh, uh, this is this actually is less than 45 kilobytes. So again, I'm not imposing here something like you should follow is the 100 kilobytes, but you should have a cut a code budget. Now, if only we have waived this, okay, which make the React DOM the most heavier part of the entire React application, okay, then the idea here is to, once you're able to see how code splitting are and how we can use code splitting in our code base. So for example, here we're going to take a look at the Visual Studio Code. There you got it. Let me see if we can actually see that. There you got it. Okay, perfect. No, but I want you to show this. Exactly. Are you with me? Okay. Yeah, you are with me. There you got it. Okay, exactly. So here what we did is just to say, hey React, I want you to now make this particularly components to lazy loading. In other words, is that Vite is smart enough. So when you use this lazy and suspense component, something that we're gonna talk about that from React, and then you say you wrap them into a function to say, hey, I want you to import this. This import is part of the JavaScript EX6, where you cannot tell, hey, I want you to, or statically import your components, or statically import files here, or dynamically import files here. So once you tell JavaScript which dynamic import you want to return, which will give this, will make a promise, and it will return you is the model per se. So the import here will return you is the model. So this function from lazy is that you are telling to React, hey, in this particular React component, I want you to load later on. So Vite, our dev server, is smart enough that when he reads this, he say, hey, okay, I'm not going to render these elements immediately. The question is that how Vite does know, or how Vite, or where Vite store this uh, data. You know what I mean? Uh, that's a very, very interesting question here, because with Vite, what you're saying is that whenever a route match here, in this case, whenever a route match here, match this, uh, which in our case is that whatever our match route here, okay, wherever you are need to call that component on a route, then you're going to actually call that, right? So it means that based on the route that you are loading, you're gonna fetch is this particular component, and the other routes you're not, pretty much. So this is detail and search pattern, right? So because search patterns is actually in our main route when we get in, so now we're saying, hey, I want you to React, do the code splitting behind the scenes. What it's doing is to doing this code splitting business. Uh, when you ask for data to be loaded here, and say, hey, this is the component that I want you to render when the route match. So now that we tell, because here we're telling to React, hey, this is a component that I want you to load later on, what will happen when we hit something? Okay, what happened when we hit? What happened when we hit? What happened when something? Okay, what happened when we hit something? So, for example, here, nope. It's like what happened when we hit something? Okay, what happened when we need exact? But what happened when we hit something that needs to load? Okay, for example, in this case, what happened when, so initially it will route a search pattern. Okay, if you would want to load that, you can configure your application to load at this route, okay, or to load at a particular route. For simplicity, the root folder or the root here. Okay, but what happened when what happened when something what happened when we what happened when something we hit is that what happened when we hit something that we need to load. For example, the details. Okay, what happened when we hit something that we need to load, and that is, well, what's happening here is that we need to find a way to show something. Okay, so when something is loaded, we need to find a way to actually indicate to the user, hey, we're loading something. And that's what we have here, suspense here. So with suspense, which is a React component, now we're going to pass in something called fallback here, where we're going to indicate, hey, when something is loading, so you're gonna show is this fallback. Okay, so basically here what suspense does is exactly. So basically here what suspense does is this. So the up when we hit the run when we hit or if you hit something up here, which is here. So if you hit something up here in the render tree, uh, show the fallback suspend. Okay, show the fallback until suspend has returned. What does it mean this? Because this will show something when we hit. This will show something when we need. So this will show something when we hit something to load. Okay. So fallback will show something when we hit something to load. And when using suspend, we're saying, hey, this particular tag or at the up on the render tree, when we hit suspend, you will show fallback until suspend is returned, which means until you get something, in this case, until you get the particular component here. So there are this particular approach of doing things, okay, because you can see here right now, you're not able to see that. There you got it, exactly. So as you can see here is mm, uh, as you can see here now, behind the scenes, uh, React is doing this code splitting business by creating chunks of it, you know, and as you can see here, code splitting of no model with beat depends. So beat actually behind the scene is the one who creating is this in combination with React. Okay, uh, this can be quite hard to understand what is this because how beat works in depth. The way beat works is that actually, okay, the way beat works is that it actually is using the browser built-in model loader. Something interesting, the browser built-in model loader for all your local server things. Question here, what are the browser built-in model loaders? This is a valid question to ChatGPT. So because now the browser has now this browser built-in models, which is JavaScript models, okay? And this is just a little background of how do we actually encapsulate our JavaScript code. So before or in the early days or back in the old days, you have something called immediately invoke function expression as a way to create this closure or this function that hold is all of the reference variables here, and then things like CommonJS, which is something that was developed at Node as a way to now modularize your code, was used. Then something down the line, we use things like UMD as a way to unify is the way of how the browser create models with the way of the Node server create models. So that's where we have model systems like Require, Webpack, and Babel. But as you can see here, that those are model systems. But with the advancement of the JavaScript, where now we can use is or thanks to EX6, okay, now we bring is the modularization to JavaScript, whether it's on to JavaScript, which is working now in the browser as well as in the server with the import and export. Now we have, so now JavaScript natively support is this ability to modularize, ability to now have self-contained code. So javascript.statement.import. So yeah, pretty interesting. I'm not sure if, but again, well, this is describing is this background. So it's now JavaScript that has this built-in model of that, and that's one of the things that you are heavily look out there in the wild. Why a lot of people that are creating models or self-contained code, they use models for that. Uh, Now this is something that is built in, which makes our life much more easy for that. And also to test our code, which is one of the things that JavaScript lacks of that. Testing our code was very horrible. So, yep, that's right. So this is just describing is a little bit of this particular JavaScript feature. Okay, so how you can now do is this static import or static export. You can see static export and static import, and then um, how you can now is requests for data, okay, which is now importing features into JavaScript like this. So pretty much here. And the other is importing models using import map. So yeah, as we saw, how a browser can import a model user, a model specifier that is either an actual URL or relatively URL that is resolved using the base URL of the document. Exactly. That is resolved based on the based on the URL of the document, the base URL of the document. So import maps allow developers to instead specify almost any text they want in a model specified when importing a model. The map provides a corresponding value that will replace the text when the model URL is resolved. Which means that, for example, the import key is the import map below defining a model specifier map, JSON objects, where the property names can be used as a model specifier, and the corresponding value will be substituted when the browser resolves the model URL. The value must be absolute or relatively URL. Relatively URL are resolved to absolute URL addressing. So the idea here is that you can now shape, the value must be absolute or relatively URL. addressing using the base URL. So the point of this is that now you can is map using that. So with this map, you can now use the property name above model specifier. If they're not trailing forward slash on the model specified key, then the whole model specified key is matched and substituted. For example, below we match bare model names, okay, and remap a URL to another path. Bare model name as model specifier with this, and then you get is this. Remap a URL to another URL. So the point of this is to look at how now, by relying on these model features that are from JavaScript, okay, and this is being used as a way to unify is how those models are being loaded, okay, model resolution, whether it's on the browser and on whether it's on the browser or on the server. Now, okay, we can actually uh, let the dev server, in this case Vite, handles that, because Vite works is by using the browser built-in model loader for all of your locally server things. Okay, for all of your locally server things, Vite is using is the internal, again in development. Vite is using is the internal or this browser built-in model loader or the import and export. So the chunk business is coming from React. So when you are loading this in production, it launches chunks of that. Pretty much here. So when you load this in production, that's what it's gonna do. So what's really cool about this is that we can load is the help page only when it is required. Again, this particular approach with code splitting, and the reason why we are looking at code splitting is because first, we described that the reason of looking at code splitting is for React performance, is for performance. And now, something that back in the old days didn't happen, but now code splitting and server-side rendering plays well together. So, for example, when you need to stay under something or performing timing to hit something, okay, the idea of having a code budget is something important. Following is the web vital metrics, but by having this uh, code budget, you can now guarantee that your user experience is as much you're making the life of your users better, not worse. Why this is important? Because if you're building an application, for example, um, yeah, if you're writing an application, for example, to Ubercopter, okay, you can safely assume that they will have is nice phones and decent connections, so you can probably have a pretty high performance budget. But for some, but it, but for writing something that keeps the well, but for writing something that keeps tracks the uh, farmer that's watering their crops frequently out of the boonies, that they have terrible 2G connections, uh, whether that's rural South Dakota, Australia, India, La Pampa in Argentina, or Amazonas in Brazil, your budget is very sensitive. That's the whole point of looking at this code splitting, is to identify is those particular use cases. The problem is that most of the time you're gonna rely or you're gonna write applications for, this is more like a product vision. Okay, yeah, this is more like a product owner vision, product manager vision. Anyway, so the whole point of this is that uh, you are now, yeah, the point of this is that by looking at the code splitting and the reason of why we're using code splitting as a way to improve the user, as a way to make the user experience better, not worse, by having a code budget, for example, to stay under something or performing timing to hit something. Okay, so by recognizing that particular budget is because you are now going to be very sensitive depend on the type of application you're writing. So if you're writing if you write an application for Ubercopter, you can pretty much assume that you will have a very high budget. They will have a nice phone with decent connection. But if you write an application uh, that's tracking something, or that is tracking is that's the that keep tracks that keep track of our farmers that's watering their crops, something out of the bunnies. So, for example, in La Pampa, in Australia, India, South Dakota, Amazonas, in Brazil, so your budget is very sensitive. Recognizing these particular cases, most of the time you're gonna end up writing applications for people that have money. You will end up writing application for people that have money. That's what happens. For people that have pretty high budget. And then down the line, you can now uh, write application for them. So because this is also interesting in the internet here, on the internet, on the internet, on the internet, um, internet access worldwide statistics. Exactly. One third of the population is not connected. So the the idea of looking at this, right, is to an according internet connectivity. So and according to Statista, this think tank, so one third of the population is not connected to the internet. That will create is a massive gap here. A lot of people are talking about is the wealth gap, that kind of thing. But I'm talking here about is the uh, data access, information access gap, which is very, very, which is real. So the reason of me showing that is because the vast majority of the application would end up, you're gonna end up building is for this two-third. You're not gonna build application for one third of people that are not connected to internet. It's like there is no business, there's no exchange of value. Okay, but that's the whole point of looking at this. Okay, so with code splitting, what is code splitting? What is the promise? What is the value proposition of this? And by having a code budget, how you can now, depending on the type of application you're writing, you can see if you have a flexible and pretty high performance budget, or you have a very sensitive one. So this becomes very helpful where you're going to split things up on the main package. Okay, so here this actually have a real life implication. As long as people have devices, then they're gonna have real life implications. So uh, most of the time what we did is just a um, split things out with the out of the main package, and we're gonna split that using different routes. Okay, here that actually is no-brainer strategy. You know, that's a no-brainer strategy here. You can take a lot of other different strategy here, uh, but once you know what you're splitting here and using is the library that allows you to do the splitting, depending on the type of application that you're writing and the code budget that you have, following is the web vital metrics is a good guideline. Uh, in the case of React, how you can use this um, function that allow you to say, hey, dev server, or hey server, I want you to, whenever you look at this particularly React component, don't render immediately. Hold on, wait for it. And then another valid question will be, where are you going to hold it? Okay, where are you going to hold that? Something that we're going to talk about right now. But the idea here is that once you uses this code splitting function from React, and then uh, you also indicate as a way to improve user experience, what will happen when something that we tried, what will happen when we hit something that we tried to load? That's what we use suspense. And suspend is, in the case we put that at the top of our render tree, okay, it will look at the top of the render tree and show the fallback until suspense returns something. So with that, uh, particularly when you want to do code splitting, beat behind the scenes is the way how it works is by using is the browser built-in features. And again, the entire reason of doing this is that first, now you can define as a fallback when you try to hit something to load, and you are now loading is the chunk of your data, or you're now uh, code splitting your applications to you're splitting is the main bundle. You're splitting out things from the main bundle. The question is, when can we do that? So pretty much you want to do that where you have tens, uh, uh, tens of kilobytes of data. Okay, that's when you want to split that out. Again, this is not a silver bullet, uh, but please measuring that you're making the user experience better, not worse. Completely, completely. So please measuring that you're making the user experience better, not worse. Again, code splitting is not a silver bullet for performance, uh, and it's not you don't always nest you don't always need to do this. So this can become pretty much like a game shell performance. So if you move something to make your initial pain faster, uh, I'm making my time deck interactivity worse. you know, you have to be careful here. I love this also analogy of the um, uh, of the of the shell game. The shell game. Okay, yeah, this is pretty much like the shell game. Like if I move something to make my initial rend, if I move something to make my initial rendering, or if I move to make my initial paint faster, I'm making my time deck interactivity worse. You know? So, el juego de la bolita in Spanish. El juego de la bolita in Spanish. Okay. So if you have a big app, you need to do code splitting to get a decent performance. So where the code is rested, okay? So where the code rested when you do lazy loading, okay? That's a very valid question. Where this code is holding, where the code rested. Ah, finally, finally, we're getting to it. We are getting into it. All right, let's get it.
Very valid next question. Suspenseful. Once this function or
will it be downloaded?
Okay. Any questions about code splitting?
Where does the code rest when we put it lazy? Will it be?
Where is the code resting? When you it's like when you put lazy.
Be downloaded immediately once that
Will be downloaded immediately once the app loads. Exactly. Will be downloaded. Exactly. Will be downloaded. Loaded immediately. Okay. Once the app, yeah, will be downloaded immediately once the app loads. That's a very valid question.
or downloaded only when required.
Or downloaded only when required. It's like holy moly. Okay, so where the code rested when you put lazy. So will be downloaded immediately once the app loads. Okay, will be downloaded immediately once the app load, or downloaded when it is required.
So what happens here with like import? Right now, the way that we have this set up, modal will only be requested.
Mm-hmm. So right now in our setup, okay, let me see if this, which is for example here. Oh no. Okay, right. So right now in our setup, which is the app.vsx, it's impressive how now I get to used to this. It's impressive how I am get used to this. Holy moly. 5 months ago, not at all. Not at all.
Notice this is a function, right? Once this function is invoked, right? So lazy will only call this function once it's actually trying to be rendered.
Exactly. So lazy now will call the callback once it tries to render. That makes a lot of sense because after all, that's the whole point of React is render. Hey, you're trying to render this? I'm going to load this. So lazy will only call this function once. Exactly. So lazy will only call the callback function once when you're trying to be, it's actually trying to be rendered. When it's trying to be rendered, it's trying to be rendering. Exactly. It's trying to be when it's trying to be rendered.
right? And then suspense will catch that, and suspense will allow that to be.
Mm-hmm. So suspense will catch that, meaning that it's a, because actually these two functions works together with lazy here, lazy react. Okay, exactly, exactly. It's actually load pretty fast, bro. It's actually load pretty fast. So this is part of the API with Arg and with React. Lazy. Hey, we need to load now this function on lazy. So now that your component code, exactly, lazy loading component with suspense. So now your component code loads on demand. You also need to specify what should be displayed while it is loading. You can do this by wrapping a lazy component on it or any of it is padding here. Exactly. Exactly. So which means that you're saying, hey, I want you to now load this markdown here, delay for the demo, okay? And then you're going to now import that here. This delay with demo is exactly. It will return as a promise like this. So when you click here, loading, and then you should load that. You're dynamically loading. You're loading that on demand, which is very, very interesting. But you do this is for bundles that are that have tens of kilobytes. So for example, if your loading is moment.js, or if you're loading any markdown, or if your loading is what you see is what you get, that makes a lot of sense. That makes a lot of sense. For default function in Markdown editor, show preview, show pets, Markdown, set Markdown. That's right. So here you are actually is returning this text area label. You're gonna show preview, and then you define is a suspend for loading. This loading is a component. Okay, exactly. This loading is a component, a functional component here, or a dummy component. And here's when you use this function to say, hey, then you to set immediate this from remarkable npm package. That makes a lot of sense. And that also is, for example, come on, what the fuck? Okay. that was a very valid question. When this code is loaded, or where is where is the where is this code rested when you put lazy? Okay, so in our case, suspense will catch that. So hey, you're trying to hey, the route here, okay. So hey, someone is actually trying to load this, okay. Hey, someone or in the logic in your application says me that you want to load is uh, this component, right? The detail here. The logic in your application say me that you are trying to load this component. What should I do? So when the URL changes here, it seems like that's what is happening here. Mm-hmm. This code relies on dynamic import, exactly. So now that your component code loads on demand, you also need to specify what should be displayed while it is loading. You can do this by wrapping is this. Learn more about managing state with suspend. Reference React. Suspends let you display a fallback until its children have finished loading. This is a component that is now being used on Vue as well. But again, Vue have that as an experimental feature. And Vue is now using a lot of the tools from React. Okay, so displaying a fallback while content is loaded. This is all the use case, revealing content together at once, revealing nested, and that kind of thing. So this is props and caveats. React does not preserve any state for rendering that got suspended before they were able to mount the first time. Okay, if you suspense was display content for the tree, but then you suspense again, the fallback will be shown again unless the updating causing it was caused by start attraction or use the fair value. So there's some caveat here. If React needs to hide the already visible content because it is suspended again, it will clean up layout effect in the content tree. When the content is ready to be shown again, React will fire the layout effect again. So okay, let me keep looking at what he mentioned here.
Pause while we load modal in the background. A very valid next question.
Suspend will catch that and pause according to you.
And then suspense will catch that, and suspense will allow that to be paused while we load modal in the background.
Mm-hmm. And pause while be loading the dynamic import in the background.
A very valid next question to ask there is, can we get optimistic about it? Can we?
Another very valid question about it is, can we be optimistic about it?
Load stuff in the background.
Can we load stuff in the background?
The answer is yes. We definitely can.
So the answer is yes. You definitely can.
We're now adding like another factor of complexity here by doing.
We are now adding another factor of complexity by doing this.
Doing that. The best way that I found to do that is you have a
Okay. So the best way you yes the best way that I found you to do that is by using service worker. Again, because now we are delegating is all of this tasks in the background, okay? Tasks in the background uh, when you are dynamically import components here, but when you are delegating is this task that you want to do behind the scenes, okay? All of this deferred activities, all of these dynamic imports.
service worker. If you're not familiar with service workers, basically what they do is you have your application.
If you are not familiar with service worker, is basically saying
You have your API server.
exactly you have you have your app, you have your application and your API.
A service worker sits in the middle, so any
Mm-hmm. A service worker sits in the middle, pretty much like an API. Yeah, pretty much like an API get. Jesus. Pretty much like an API gateway or an API rate limiting, okay, that sits between the server and your application as a way to do something. In the case of API rate limiting, guarantee that whoever is making these requests is not abusing of that. How so? By allowing you to do requests per second, giving you a threshold of how requests you can do per second. And with that, this is pretty much like now the service worker. But you have your application, but the perspective here, so the API rate limited sits, or the perspective is by sitting on the API. Okay, this is something. This is like my the the bouncer before me. Okay, where now but this is on the server. So this is the bouncer that sits in front of me. The API rate limited or the access control list server, all of it. And now for the service worker, it's from the browser perspective. Okay, so now this sits between this API and my application and the browser. This service worker sits in the middle.
anytime that your application makes a request
Mm-hmm. Right. So your applications makes requests to them.
to your API, it goes through your service worker.
Mm-hmm. So your application makes requests to your API.
You have your application, you have your API server. A service worker sits in the middle, so anytime that your application makes a request to your API, it goes.
Mm-hmm. So anytime, any anytime your application makes requests to your API, okay. Yeah. So anytime your application makes requests to your API, it goes through the service worker and out of the and out of the and out and out to the API. Mm-hmm.
It's through your service worker and out
Exactly. It goes through your service worker and out to your and out to and out to the API.
to the API, right? That's just how
Mm-hmm.
service workers work. What you can do,
So that's how service workers do. So that's how service worker does or do.
is you can basically have your service worker, once it loads, once your app is loaded, you can say, okay, the user is trying to load modal, the user might try and load details, they might try and load this. So they basically go and grab all of the pieces in the background so that whenever modal gets requested to the service worker, it can just say, guess what? I already have it. We're not going to talk to the API right now. Here you go, right? And so by having that service worker sit in the middle of that, you can basically just like serve those requests as if they were happening instantaneously, and your user never has to know, and you don't have to write your code any differently either. The service worker can handle all of that. So the way that you do that is you have Vite or Parcel or Webpack generate a manifest of all the chunks. The service worker, once it's loaded and once your app is loaded, can look at that manifest and say, all right, go give me all of those chunks, and then it'll do that for you. Something like Remix actually does this for you already. It's actually one of the cool parts of Remix, that they kind of take care of that entire architecture for you if you do it correctly. But it is possible to do yourself as well. Hopefully you can see why I'm not teaching that today. It's like another half hour that we'd be going over setting up service workers, and this is not a class on service workers. So, is there a class on service workers, Mark?
We actually have
Mm-hmm. Holy moly, that was a year ago. Web app lifecycle, service worker background API, visibility. Mm, interesting. A journalist. Is he? Mm, mm, holy hell! Holy moly! Mm, that's very very interesting. Mm. Holy hell. Okay. That's interesting. Mm-hmm. Okay. Mm. 3D Gaussian splatting. That's interesting. Mm, okay. That was very, very interesting of him. That was very, very interesting. Was very, very interesting. So he is from Buenos Aires. Mm-hmm. Okay. Interesting. Very, very interesting, by the way. Very, 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 very interesting, my friend. Okay. All right. Okay. Okay. That's interesting. That's completely interesting.
Two. We have one on progressive web apps with Maximiliano Bergman,
Okay, that'd be a good one.
and we also have a deep dive on service worker with Kyle Simpson.
Yeah. So those would be, if you don't know what I'm talking, you have this set up.
Okay. But the idea here is that recognizing is first what you're doing here with lazy. Okay. And especially the idea here is to get this particular model and defer when you want to load that. In other words, only load what is required. The question is that when we use lazy from React, what this code is doing. So where this code rested, um, and because you're passing as a callback to the lazy function, uh, this will load is uh, so because the way how we using is suspense, so is this. So lazy load will be load this particular component. So suspension will catch that, pause while loading or showing this loading, uh, and pause will be loading the dynamic import in the background. I think the way how it actually making this.
Any question? Notice the question asked there is factor of complexity here. By doing that, the best way that I found to do that is you have a service worker. If you're not familiar with service workers, basically what they do is you have your applications to
Mm-hmm.
the API, right? That's just how service workers work. What you can do is you can basically have your service worker, once it loads, once your app is loaded, it can say, like, okay, the user is trying to load service workers work. What you can do is you can basically have your service worker, once it loads, once your app is loaded.
Okay. The way of how you can have your service worker is that once your app is loaded,
It can say, like, okay, the user is trying to load.
exactly. So once your app is loaded, it says the user is trying to load model.
Modal, the user might try and load details, they might try and load this.
Okay, the user is trying to load model, might try to load details.
So they basically go and grab all of the pieces in the background.
So they basically grab all the features in the background.
So that whenever modal gets requested to the service worker, it can just say, guess what? I already have it.
So whenever we request something, the service workers say, guess what? Guess what? I already have it.
We're not going to talk to the API right now.
Exactly. I'm not gonna talk to the API. I'm saving a request.
Now, here you go, right?
I'm not gonna talk to the API. Now, here you go.
So that whenever modal gets requested to the service worker, it can just say, guess what? I already have it. We're not going to talk to the API right now. Here you go, right?
Okay, here you go.
And so by having that service worker sit in the middle of that, you can basically just like serve those requests as if they were happening instantaneously.
So by having it a by having a service worker, you can set up in a way that act as if happening uh, that acts as an if happening instantaneously.
Here you go, right? And so by having that service worker sit in the middle of that, you can basically just like serve those requests as if.
Okay, so by having a service worker, you can serve those requests in a way that act as if happening.
They were.
Okay, or as if they happening, as if they happen, as if they were happening immediately, instant, instance, instantaneously.
Happening instantaneously, and your user never has to know, and you don't have to write your code any differently either.
The user never knows, and you don't have to write your code differently. How is that? By using it as a manifest. The service worker, exactly, the service worker can handle all of that. The service worker can handle it, all of that.
The service worker can handle all of that. So the way that you do that is
Exactly. Now he's explaining how you do that. How do you do that? Okay? Because here now we're talking is about service worker. Service worker. And this is when you want to do task behind the scenes. Service worker. How do you do that? It's by having a
you
manifest.
have Vite or Parcel or Webpack generate.
So you have Vite, Parcel, or Webpack. Any model bundler, any model bundler generating a manifest of all the chunks.
A manifest of all the chunks. The service worker, once it's loaded and once your app is loaded, can look.
Exactly. So the service worker, once it's loaded, okay? So the service worker, once it's loaded and your app is loaded,
look at that manifest and say, all right,
uh, can look at the can look at that manifest and say, okay, here's the request.
go give me all of those chunks.
Go get me all of those chunks,
and then it'll do that for you.
and they will do that for you. All of those chunks that I needed to. But this is if you want to do this code splitting techniques as a way to improve the performance or the perceived performance of your application.
Something like Remix actually does this for you.
Something like Remix actually do that for you
already. It's actually one of the cool parts of Remix that they kind of take care of that entire architecture for you.
They kind of take care that entire architecture for you.
If you do it correctly.
If you do it correctly.
But it is possible to do yourself as well. Hopefully you can see why I'm not teaching you that today. It's like another half hour that we'd be going over setting up service workers, and this is not a class on service workers. So.
But you can do it for yourself. But that's the way how it works, is by telling to any of these web bundlers, whether it's Vite, Parcel, or Webpack, they generate a manifest with all the chunks that you indicate in your applications. Hey, this is the chunks, or this is the code splitting, this is the React components or the models that I want to load uh, dynamically. In other words, I want to defer the load of that. So you indicate that to any of these model bundlers, Vite, Parcel, or Webpack, to generate this manifest that contains all the chunks. So when the service worker and your app is loaded, they can look at the manifest and say, okay, go get me all of these chunks, and they will do that for you. Holy moly. Why are we doing this? As a way to improve the user experience. As a way to improve the perceived user experience by relying on service worker. So now your app load faster, and perhaps this might be something trivial. In fact, this might be something uh, important for large application. Oh my God, yeah. This might be something important for large application. Okay. This might be something important for large applications, and especially beneficial for large applications, whether it's for public face applications, e-commerce, yeah, I will read it, any public API applications, or for this internal application as well. So for example, if you need data fast, a good example of this is if any of those. So for example, if you're working in the oil industry, for those who are on the oil industry, especially those exactly. But how do you say this? Not quite sure how you mention that. Like this. Upstream, midstream, downstream. In English, please. Be my yes here. Oil patch hotline. In, in Slovakia. But Galician as well. Interesting. Refinery. Exactly. Refineries. The thing is refineries, refinery, um, oil refineries, oil, water, oil refineries. But this is refinery. But how do you say that platform? Oil platform, maybe. So, oil platform. Exactly. It's an offshore platform, oil platform, like this. Offshore oil platforms for drilling completely. Oil wells just offshore at Summerlin, California. Yep, oil wells, offshore platform Gulf. Exactly, offshore platform. Type of offshore oil and gas structure. That's right. Spar, semi-submersible, floating production, fixed platform, compliant tower, semi-submersive platform, jack-up drilling rigs, spar platform. And even have they have different types of platforms. Type of offshore oil and gas structure. Compliant tower, deepest, Chevron Texaco Patronus. Compliant tower, 4 and 5, vertical moor, tension leg, and mini tension leg platform. Deepest, Magnolia, spar, semi-submersible, floating production storage, semi-submersive, spar, deepest, spar. But as you can see here, in the case of this particular industry, of the oil and gas, an application they're gonna build for them, is that for those oil offshore, I'm not sure they're not gonna do that, by the way. But if you're writing an application for oil shore, if you're writing an app for oil shore oil offshore. If you're writing an app for workers at of an offshore oil gas of an oil if you're writing an app for an offshore oil and gas, okay, you definitely want to use service worker, or you can assume that their connection, they sometimes will not have the best connection. The device might be good, but for those use case, you definitely want to now split out the main bundles in chunks that are required when needed. That's the entire reason of this. For mission critical applications, that's when it is required to do this. It makes a lot of sense. It makes a lot of sense. Holy moly. Totally, totally. And that's one of the reasons of this service worker. It's like, hey, because we wanted to now establish a connection um, fast as possible and to improve performance. So the service worker sits between the browser and the server. So any request that your app is, so any request your app, so any request, okay. So anytime your app make a request, it goes through the service worker. Uh, it goes through the service worker first. Okay, it goes through the service worker first and out of to the API. So that's how service workers do. Okay. For example, if you want to load is a detail or a model, so the service worker basically will grab all of this in the background. So whenever we request something, the service worker say, "Hey, guess what? I already have it, and I'm not going to talk to the API. I'm not going to make a request, and saving bandwidth, uh, and saving request bandwidth as well." So by having service worker, your server, those, so by having a server worker, your server, so by having a server worker, you serve, which is this. So by having a service worker, you serve those requests as if they happening instantaneously. You give the illusion of uh, this immediate. You give this you give the perceive uh, uh, you give this perceive illusion. You give this perceive improvement in the user experience. So you make, so by using the service worker, you serve your request as if they happening instantaneously. So the user never know what's so the user never knows, and you don't need to write your code differently. So the service worker can handle all that for you. And the way how it works is by telling to any of these bundled modelers, whether it's Webpack, Vite, Parcel, they generating a manifest that contains all the chunks. So when the service worker in your app is loaded in the browser, now they can take a look at the manifest and say, okay, go get me all of these chunks. And they will do that for you. So Remix actually do that for you. They take care of the architecture for you if you do it correctly, but you can do it yourself. Oh my God. Holy moly. Holy moly. Now you understand truly the need of code splitting here uh, totally. And when you can use this code splitting as well. With that, that'll be all for this video. Take care. Bye bye.